We are starting today's topic, chemical equilibrium. Now, when we say chemical equilibrium, we have to study about two types of reactions, reversible reactions and second are irreversible. When I say reversible, I mean reactants are combining to give products and products are recombining to give back reactants, as we have shown in this reaction. A reacts with B in gaseous form and gives C and D in gaseous form. Physical state of the reactant must be mentioned in these all areas. Now this reaction is proceeding forward as well as backward. But in irreversible reaction goes to completion. Just like I write silver nitrate added to HCl. A precipitate of silver chloride has formed. Now this silver chloride has come out of the reaction and we have got HNO3 in solution. Now since this silver chloride has gone out of the reaction, so there is no possibility that silver chloride will combine with HNO3 to give back reactant. So reaction is irreversible. Now reversible reactions may be known, may be unknown, may be homo, may be hetero. For example, you know a well-known reaction, Haber's process. Haber's process. Everybody knows this reaction is ammonia preparation. It's ammonia preparation N2 plus 3H2 reversibly giving 2 ammonia. This reaction is very well known and it is also homogeneous. Homogeneous. When I say homogeneous, we mean all reactant and products are in same phase. All in same phase. You may have also known contact process. You study this very well-known reaction, contact process. 2SO2 gas plus O2 gas, reversibly 2SO3 gas. Contact process for preparation of sulfuric acid. If there is a reaction is hetero means reactants and products are in same, not in same phase but in different phase. Let me write a reaction of steam on iron, very well known reaction. Must have heard the name Lane's process. Lane's process. It is solid. His action by steam forming reversibly Fe3O4 solid plus 4H2 gas. Now here you can find out it is a solid, it is a gas, it is solid, it is a gas, it is heterophases. There may be any hypothetical reaction. When I say hypothetical, I mean that I have a reaction H2 plus I2 reversibly giving H2I2. Why we call it a hypothetical? Because we never heard any compound like H2I2. So this is a reversible reaction given as hypothetical. We may make any reaction hypothetical. You may have H8 reversibly giving 4H2 gas. You never heard H8, but we should not bother about. We are simply studying chemical equilibria, where simply we are giving the reactant and product, and you have to see that reaction itself. We may be given reaction like X2, Y2, reversibly 2XY. Most important thing in chemical equilibrium is we must be given physical state of all these reactants and products, but sometimes they are not given, and reactants and products are hypothetical. Take them as a gas. If they are not given, take them as a gas. Be careful, because physical state is a must for any reaction. Now, chemical equilibrium may be between solid and liquid. Just like you have ice, reversibly with liquid. You may have allotropic forms also, allotropic form. We may give you sulfur rhombic in equilibrium with any other form S42. So it can be any allotropic form, it can be solid liquid, it can be gas with gas, or anything can be given. You have to simply look your reaction. So first point is reversibility. Second point, we have to heard a law called law of mass action. This is given by scientist Goldberg, so sometimes called as by the name of Goldberg wage law. What it says, rate of reaction R is directly proportional to product means multiple, product of active masses of reactants So if I give you reaction N2 plus 3H2 reversibly 2NH3 gas phase, so I can write rate of forward reaction, F for forward, directly proportional to reactant is nitrogen, power 1 because coefficient is 1, H2 power 3 because coefficient is 3. So this is the rate of forward reaction. So if I remove the sign of proportionality, I can write a constant K1 and 2 H to the power 3. Here K1 is called rate constant. It is called, what we call it? Rate constant of forward reaction. This is rate of forward. Let me take backward reaction. I'll write the word RB, B for backward. So now reactants are what? Now reactants are ammonia. So coefficient is 2. So write is ammonia 2. Remove the sign and get K2. K2 is another constant, that is for the backward. This is K2 is the constant for backward. Same thing, only thing is backward. So second point is law of mass action. Active mass is represented by a bracket. What do you mean by active mass? Active mass mean molar concentration. You study all the time molarity, molar, it is molar concentration, which you know already, it is mole per liter. What do you mean by that? Let we have got 5 gram urea in 1 liter water solution. So we will call molarity of urea क्या होगी? Molarity of urea will be 5 mole. Mole I have taken, not gram. 5 mole means 5 mole per liter. So this is 5 molar. I'll call it active mass. So active mass now simplified to molar concentration, which you study all the time, mole per liter. Third point is equilibrium state. What do we mean by equilibrium state? It is a state at which rate of forward equals rate of backward. Forward reaction and backward reaction rates become equal. As we can say in this case, rate of forward was this, rate of backward this. We can now equalize them. So we can write now RF is equal to RB. Both are equal. So we can write K1 and 2 H to the power 3 is equal to K2 ammonia power 2. So we can write K1 by K2. The ratio of rate constant forward to rate constant backward is known as Kc. It is called equilibrium constant of concentration. C for concentration, the one definition is, you can define it as ratio of rate constant forward to rate constant backward. We can also define Kc as ammonia to the power 2 over N2 H to the power 3 as a product of, product means multiple, product of molar concentration of products, ऊपर लेना है products, divided by product of molar concentration of reactants are in denominator. Stoichiometrically you have to follow. So Kc you have defined two ways. One is the ratio of rate constant forward to backward, and second you define product of molar concentration of products divided by molar concentration of reactants stoichiometrically. This is expression for Kc. Now we have to remember, this is very important, remember. Active mass of solid. The solid mean I have taken calcium carbonate, but I have not dissolved in water, I have not made any solution, it is insoluble in water. So I will take calcium carbonate mass of solid as 1. You cannot take it 0. You cannot take it greater than 1. You cannot take it less than 1. Solids, like I write solid somewhere, Fe solid, calcium carbonate solid, calcium oxide solid. Anywhere solid is given to you, you are not put in the expressions. What you mean by that, not put in the expression? I write a reaction. Calcium carbonate solid, reversibly, calcium oxide solid, plus CO2 gas. Now you can see this is solid, this is solid. I am writing Kc of this reaction. So now this to be not written. In the expression they will intentionally write like this: calcium oxide, carbon dioxide over calcium carbonate. But this is wrong. Don't take them. Take that as 1. So Kc will be simply concentration of carbon dioxide. You have to write the expression for a reaction Fe. 3Fe solid plus 4H2O gas, reversibly Fe3O4 solid and 4H2 gas. You are asked to write expression of Kc for this. So be careful. This is not to be taken. Take this H2. Stoichiometrically power 4. This is solid, not to be taken. Take. This is water in gas form. Take this.